Hello everyone, today we're going to be covering the Registry Persistence Detection Room from TryHackMe. We're going to learn to use the AutoRuns PowerShell module to detect persistent mechanisms that use the registry. Awesome, my name is Dr. Speechtalk. I'm a cybersecurity analyst and boosting content creator. Let's get started with the room. Alright, so starting off with task 1, intro. We're going to set up the virtual environment, so we're going to join the room. Got it. And we should, yes, start lab machine and start attack box. So we're going to start up both of those. Nice. And we'll give them time to load. So we have both. So let's get started with the room. Alright, let's do this. One crucial step that malware does upon successful execution on a lab machine is to ensure that it can stay there even after a reboot or removal attempt. This is possible using various techniques, collectively called malware persistent mechanisms. This room will give you an overview of these techniques and introduce a tool that can help detect them and aid in removal. The learning objectives for this room can be found here. We're going to learn how malware persists in a machine. We're going to learn how malware uses the registry as a persistence mechanism. We're going to learn how to use the AutoRuns PowerShell module to detect and remediate persistence mechanisms. And so, let's get started with connecting to the machine. So, like what the room says, we're going to use the lab machine provided to complete the task in this room. We can start it in split view, which we have done. And so, we're going to give some time to start up. Alternatively, you can connect to the VM using the credentials below via remote desktop, your username, your password, and your IP. And so we're going to start, and we started the machine, and we logged in. So we're going to click check. Nice. I always got to like those correct answers. Sweet. But let me decrease the volume just in case. That was loud. Alright, let me view in full screen so that way we have the view better for the eyes. Give that time to load, and we should have both our registry machine and the attack box. And since we are talking about the Windows registry, yes, we're probably going to have a Windows machine. There we go. Let's, come on. Administrator, that's awesome to see. Give it some time. And we should be able to see the machine. By machine, I mean the registry persistence. Alright. I see it loading. And nice. Everything looks good to go. Alright, let's do this. And then I'm going to exit split view. Awesome. Alright. Task 2. Intro to malware persistence mechanisms. The term malware persistence can be defined as behaviors that enable malware to remain on a system regardless of system events, such as reboots. There are multiple ways malware can gain persistence. The technique used vary depending on the target operating system, ease of implementation, level of stealthiness, or sometimes based on the preference of the malware offerer. Examples of these techniques would be modifying an operating system's boot sector, installing malicious configurations, or hijacking execution flow. In Windows, the most common and easiest to implement a technique is the abuse of Windows registry run keys. Also, for more background information, the Windows registry is a database of low-level operating systems and application settings. The run keys are specific keys within the registry that contain a path that runs every time a user logs in, and they are listed below. To view these keys, we need to open the registry editor by searching for regedit and on Windows search, or by double-clicking on the red edit icon pinned on the Windows taskbar. There we go. And this is what the Windows editor window looks like. If you want to view the value for one of the run keys, expand the folders and their subfolders until you reach the key you are looking for. For example, HK local machine, software, Microsoft Windows, current version, run. So that being said, we got some questions to answer. Awesome. Alright, first one. What is the value name of the suspicious window registry entry that runs during startup. So before we go about answering these questions, I want to provide you guys a really helpful additional resource. And that is the DFI reference, Windows Forensic reference tools, but also for my Linux folks, there's also a Linux Forensic reference page as well. So what this does, let's go back to Windows, is that it is a self-contained, offline capable DFI reference pages for Windows artifact analysis, in Linux as well. We can download any tool as a single HTML file and use it anywhere. For example, we're talking about the Windows Registry for Persistence. So let's click on this. And this talks about the Windows Registry for forensic artifacts. And we have the ones for auto start and persistence. Registry keys that cause code to execute at boot login or via Windows subsystem hooks. And here is the registry keys themselves and the Sigma rules. And also an explanation. The classic run once family of auto start keys across all highs, architectures, session context, and policy paths executed on every login. And if we click on it, we can see more of the registry key paths as well. So like I said, we're going to use this helpful resource for this room. And overall, I definitely recommend bookmarking this website because it is a really beneficial resource to help you better understand Windows and Linux artifacts. And the URL can be found here, and all credit goes to the author for the creation of this really helpful website. And the GitHub can be found here, so all credit goes to this author. I just wanted to shout them out. Give credit where it's due. All right. So what is the name of the suspicious registry entry that runs during startup? So let's go to this. Please let me persist. Okay, that's not it. All right, so let's click on. Is it really? All right, let's do reg edit, which is this icon. Let's click on it. And we got HK, we got software, policy system, I believe it was Microsoft. Let me go back. What is the value name of suspicious registry entry that runs during startup? So we're going to go to here. All right, runs during startup. HK current user, or the current user software, Microsoft Windows, current version run. Alright, so HK local machine, current user, awesome. Software, so we go back. HK local machine, software, Microsoft, current version. I believe it was software Microsoft Windows. Let's go find Windows. Nice. Windows, current version. And we see all these. Current version, run. Because we're going to see the keys. Information, run. We got a security health stray.exe and bogus. Whatever that is, that looks sus. Alright, let's see, let's put that as our answer. Yeah, that looks very sus. See user administrator, app data, local, that. Alright, so let's go here. Let me make it easier. I'm going to move these right here. Awesome. Value name, a suspicious registry entry that runs during startup. Include the parentheses. I believe it's just going to be this. Include the parentheses. So if I paste this, the parentheses. Alright, what is the value data of suspicious registry entry that runs during startup? I believe I have it right. Okay, good. Okay, I have it right. What is the value name? Oh, default. We got this. Booyah! Nice. Alright, what is the value data of the suspicious registry entry that runs during startup? Let me decrease the volume so that way I don't blow your ears out. What is the value data of the suspicious registry entry that runs during startup? We found it. It is going to be C users, administrator, app data, local, bat. So let's copy this and paste. C users, administrator, app data, local, this. Awesome. Alright, what string is displayed on the console when the suspicious file runs? So when we click on this to run it, we get, let me stay my friend. Let me stay my friend. Let me stay my friend. Any? Did I do it right? C user administrator local. What string is split console when suspicious file runs? Okay, so I need to go to C users. Did not make this easy. Alright, so let me go to C users. So let me stay my friend. I need to go to File Explorer. Let me open up File Explorer. There we go. C users administrator. I believe it was C users administrator app data. You do not see here. Actually, let me try this. Let me go here. Let me go here. Paste. C users administrator. Administrator. Yes. Alright. C users administrator. B64. Let me stay my friend. Okay, so it's not this. C users administrator app data local 2469.bat. And I believe C users administrator app data. So can I? Okay, so I can take this because I'm in the machine. I should be able to just paste it. There we go. Now run. Please let me persist. Yes, there we go. That's the answer. Please let me persist. Booyah! Awesome. Alright. Intro to the AutoRuns PowerShell module. Task 3. As you've seen in the previous task, it is possible to detect the existence of persistent mechanisms in the registry by manually checking keys. However, other registry keys can be used to establish persistence, and they are not as obvious, making them harder to find. Fortunately, some tools can help us with this problem. A widely used tool from Microsoft called AutoRuns. So if we click on this, we will see AutoRuns right here. And what it looks like, a video, introduction, and much more. But just in general, this utility, which has the most comprehensive knowledge of auto starting locations of any startup monitor, shows you what programs are configured to run during system boot up or login, and when you start various built-in Windows applications like Internet Explorer, Explorer, and media players. Awesome. How to use it as well. Navigate to the registry, disable AutoRuns usage. Really helpful information, related links, and how to download it. Nice. Alright. What this does is that it checks all possible locations where a program can automatically run on startup or when a user logs in. This tool does what we need, but it is not the one we'll be using for this room. If you still want to check it out, you can try out the sysinternals room, which is really, really awesome. And I definitely recommend looking at this one. And if you don't know what sysinternals is, don't worry. Basically, what sysinternals is, it is a compilation of over 70 plus Windows-based tools. Each of them falls into one of the following categories, like file and disk utilities, networking, process, security utilities, system information, and miscellaneous. It's all free. It's really awesome. Please go check it out. Alright, for this room, we'll use the AutoRuns PowerShell module. It does the same thing as the original AutoRuns tool. Still, it allows us to leverage the benefits of PowerShell scripting and has a baseline feature for comparing current snapshots to previous ones. You'll see why these features are essential later on. The Windows machine already has the AutoRuns PowerShell module installed. To use it, open PowerShell Administrator mode by clicking on the PowerShell icon on the Windows taskbar at the bottom of the screen. Once the PowerShell window opens, type the following to view the available commands. So what we need to do is that we need to go here, reconnecting to remote machine. Oh, please don't do this. Please be nice. Thank you. Alright, we're going to make some room. Let's do this. Close. I'll be back. We're going to click on PowerShell, run as administrator. And now we're administrator. Yes, we are. Test. Alright. Technology does not want to cooperate today. But don't worry, I got you guys. We shall not be defeated. The Windows machine has ready to use it. Open in PowerShell Administrator by clicking on the Windows taskbar at the bottom of the screen. Type the following to view the available commands. Alright. Exit split view. I need to remove this. Okay, why are you doing this? Should be working. It is doing what I don't want it to do. Alright, run as administrator. Alright, if this is being buggy, I will restart. Yeah, I'll probably have to restart the machine. Command prompt. Can I do command? Yeah, we're going to. Can I at least do a command prompt? I have a feeling this is not going to work because it's command. Okay, so command prompt works, but PowerShell does this. Windows machine already has the AutoRuns. Use it, open PowerShell. And then once the PowerShell opens, type the following. So we need to do git alright, I'm going to terminate this machine and then restart the target machine. So split view. I want the lab machine. Yes. Hopefully this works so that way I can show you guys what the intro to AutoRuns PowerShell module looks like. And then we can run through these commands, which is awesome. Alright, so which AutoRuns, you guys will check out the tools README page for more information. Please do. Nice. Nice, nice. Yeah. AutoRuns is a PowerShell module that will help to do live instant response and enumerate AutoRuns artifacts that may be used by legitimate programs, as well as malware to achieve persistence. Awesome. Alright, so what AutoRun function is used for getting and displaying the AutoRun entries? And we have a hint. Nice. Use the get help commandlet with the AutoRun commands to answer the question. Sweet. Used for displaying the AutoRun entries. Module command. AutoRun function. Get PS AutoRun. I want to say it's get PS AutoRun. Command new AutoRuns baseline. I'm going to say it is get PS AutoRun. Hey, I got that right. Function. Nice, nice. Alright, no. What I want you to do is give me my PowerShell. Let it do its thing. Alright, what AutoRun function is used for creating a baseline file from AutoRuns artifacts? And that is going to be AutoRuns used for hint. Use the get help commandlet with the AutoRun commands to answer the question. It's going to be new AutoRuns baseline. AutoRuns baseline. Nope. Do I have at least a scripting engine to access? Alright, let me try that. What AutoRun function is used? Oh, there we go, there we go. It took a while. Nice. Alright, we have it. Sweet. So if I am correct, I should be able to run commands. Command, alright. Get command module is being very buggy. Come on. Auto. I was so close. Auto runs. Nice. Alright, we got him. Nice. And then if we do get help commandlet with the AutoRun commands. So if we can do get PowerShell, can be nice. Help. Compare. By the way, I am typing. Get help. There we go. Alright, so what this function does is that it compares two baseline files of AutoRun artifacts, and it was compare -AutoRuns baseline. So it's going to be compare AutoRuns baseline. Nice. Alright, task 4, filtering AutoRuns entries. AutoRuns PowerShell has a function called PS_AutoRun that will list all possible auto start mechanisms available on the machine. It makes this list by looking at categories like the registry, Windows services, WMI entries, DL hijacking, and more. Because of this, the output of the command will return many results that might be challenging if not adequately filtered. Also, for a really helpful resource, we have DFIR script, Windows Registry Artifact Explorer, we have AutoRun and Persistence, and much more. But also we can look at other persistent mechanisms, such as, for example, keys, start when login configuration, group policy login, startup scripts, startup folder paths, LSA security packages and authentication, start menu command history, and much. Task scheduler, WMI event subscriptions, all that really great information. So if you wanted to get a better understanding of a certain concept associated with persistence, all you would have to do is, for example, click on, let's just say we wanted to look at, we were talking about WMI, so we're going to go to WMI, click on it, and it's going to talk about the registry key path and forensic value. WMI subscriptions are one of the most persistent and detection resistant mechanisms available. Tongue twister. The registry key shows subscription names, but the full definition is in the WMI registry repository. You need to cross-reference with WMI activity operational log EID 5861. Here's the parsers. So overall, what this is going to do is going to help you better understand the persistent mechanisms, so that way you understand that if you are investigating, you understand what these mechanisms are tied to, which is persistence. And also we have attack reference as well. For persistence, we have the curated registry reference, which basically what this is that it is a registry relevant technique subset, and only techniques with direct registry artifact mappings are included. This is not the full attack matrix. You can click any registry key chip to jump to the artifact view. Click technique IDs to visit attack.miter.org. So we can click on this, and it will take us to miter.org so we can learn more about the persistent mechanisms. Awesome. Alright, so that being said, get-ps1 if not adequately filter. So piping the result to out grid view can make the output more readable. Oh yes. Now wait a few minutes for the tool to finish populating the results. And the results above list all possible places a program can run on startup. You can filter the logs by specifying keywords in the filter bar at the top of the window. And you can also sort the results by clicking on the column headers. We can specify parameter switches when calling the function to filter the result according to the previously mentioned categories. Open a new PowerShell window and use the get help command to list all the available parameters. Sweet. Alright, let's do this. Alright. So we're going to go to, extend. Although extend is really helpful. View in full screen. Registry persistence. Give me my Windows machine, please. I said please. Technology works for me. Awesome. We're gonna do get help. And in this instance, we're going to do get help, useful for filtering for artifacts related to boot execution of images. And let me exit split view. Get dash help dash get. I believe it is get. I am typing. Get dash ps. Oh, come on. Get dash ps auto run, I believe detailed to see, very detailed, pun intended, information. Detailed. Booyah! Nice. And since it is a lot of information, we're going to do get ps dash so that way we can see more. Bringing results out command will make the output more readable. Sweet. Awesome. Alright, so let's go learn more about what we have with get-ps auto run. So we have examples. Sweet. We have the filters. We have the parameters. Alright, so let's go look for What parameter switch is used for filtering for artifacts related to boot execution of images? That's going to be dash boot execute. So dash boot execute. Oh, we don't need the execute. Nice. How many entries are outputted using the parameter switch from the previous question? So we're going to do get dash ps autorun dash boot. I am typing. I am trying. Boot dash execute. Oh, get help. My bad. Get help. I need to remove this. This should work. There we go. We got this. Autocheck.exe size last write time version. So I believe we get outputted. I see that there's only one entry, so I'm gonna say 1. Booyah. Alright, what parameter switch is used for filtering for artifacts related to printer drive and status monitors? So let's go back and rerun our command get dash help dash get dash ps autorun dash detail. Lots of dashes. And then let's go here and let's go look for, we are looking for filtering for artifacts related to printer driver and status monitors. Let's go find printer driver and status monitors. Services and drivers categories. I see this. Alright, let's go find services and print monitors categories. So I'm going to say it's going to be print monitors DL. Print monitor DLLs. Nice. Alright, what parameter switch is useful for filtering? We got that. Then we're going to figure out how many entries we have when we run that command with the switch. So what we're going to do is that we're going to take this and then we're going to do get dash help else. Ooh, nice. We got 1, 2, 3. Oh, we got 1, 2, 3, 4, 5, 6, 7. I believe that's 7. I see 7. Or is it 6? 8? 5. Print monitor DLLs. Or if did I miss DLLs? Alright, so we got 1. Alright, we got 1, 2, 3, 4, 5. Nice. What parameter is used to add a new column to show whether a file is digitally signed? So go find that parameter. This is fun. Boom. Digitally signed dash verify digital signature. I'm gonna say that's correct. Verify digital signature. Nice. Searching all categories, how many entries have the signed column set to false? And we have a hint. The hint is specify the verified digital signature parameter when calling get-ps autorun to get the signed column. Alright, so what we need to do is that we need to do get-ps run and then change this to verify digital signature. Nice. Oh, that is a lot of entries. And it's still going. Oh, that's awesome. Look at it go. Oh, that is awesome. And it's going. And it's still going. And it should be done. No, it's not done. Alright. I wonder if I do control. No, not control. Look at it go. Look at it go. I wonder if I can open another PowerShell window. It will cooperate. No. Alright, let's keep going. So I'm gonna say let's see if I can control. See if I can exit out. Control Z. Okay, it's stack. Okay, cool. We got administrator, so let's do get-ps autorun verify digital signature and make the output a little bit cleaner. Way cleaner. Out grid view. So let's do out grid view. Nice. Look at this. So now we're going to be able to filter on, I believe if I do signed, I should be able to get the answer. Look at this. So I'm going to full screen this. Look at all this. Publisher, signed. Where signed equals true. And do we have a count? So I got how many? They want entries. Do they want amount? How many entries have the signed column set to false? Okay. So we want the signed column, instead of true, we want it set to false. It is going to be 3. Nice. Try to answer the previous question with just PowerShell without using out grid view. Oops. 3. This is for learning purposes. Alright. Task 5. Comparing to a baseline. While filtering via parameter switches helps reduce the output, there is still a lot to go through. This is where the baseline creation and comparison feature of the AutoRuns PowerShell module is helpful. as only the entries that differ from the baseline are shown in the results. After creating this room's machine, a baseline file was generated and saved in the documents folder, which we can see here. This file serves as a snapshot of the registry before the malware ran. And to check what registry keys were changed, a new baseline file needs to be created using the new AutoRuns baseline function, which can be found here. Note: generating a new baseline file using the code above will take a few minutes, so please be patient. And when done, the new baseline file is added to the documents folder. And then the two baseline files can now be compared using the following command, which can be found here. Note: make sure there are always two baseline files in the documents folder when comparing. Delete the other files because you do not need to avoid confusion. And now we have questions answer. Awesome. Alright. There's another suspicious login entry. What is the full path of this key? So what we need to do is, I believe we still need to do PowerShell. Yes. Alright, so what we need to do is take this, reconnecting, come on technology, please be nice, thank you. Alright, I believe full path. Verify digital signature. And then we do to dash verify signature. And then it's saying that I need to do this. Nice. And then I do where type where brackets is not parentheses money underscore dot is, I believe it's 0 OS. Is it an O? Yes it is. Or is it a 0? I'm gonna say this is OS. I'm gonna say O. OS binary. If it squawks, then we'll change to 0, and then O to a 0. Then we'll do this. Then we'll do this. And then we'll do it again. New auto runs, new auto runs baseline dash verbose. And they did say it was going to take a few minutes. And then when done, the new baseline file is added to the documents folder. Yes, it is taking its time. And so if we go to File Explorer, then we go to C, I believe it said Documents. C, oh, this we see Documents. We got baseline, and then we got this thing. Successfully created. Awesome. Alright, we got our files. We got 2 files. Nice. Alright, so now let's go look, compare verbose to see them, which we do, and then let's go find the key. So let's do compare. No, it's keep the outgrid view. We're going to change this to compare dash auto runs baseline. Oh, the L's capitalized. Baseline dash verbose. Compare dash AutoRuns baseline dash verbose out grid view. And there we go. We can see both of them compared to against each other. And we see that we're trying to find another suspicious login registry. What is the full path of this key? And we have it image path right here. C users, administrator, local app data, local THM, this. Because in the previous task we found this one, the 24D9-BAT. So this one is going to be our answer. So I believe I can just click on this. You're going to make me type all this. See what is the full path of the key. So you want me to do full path of the key. Okay, so it's going to be HKLM. Then we're going to take this dash software dash Microsoft dash Windows NT current version, and then when log on. Sweet. What is the value item name of the suspicious registry entry from question 1? It is going to be user init and exe, but we want suspicious, so 789A dot bat. 789A dot bat. Why is that not right? 789A dot bat. That is the am I doing something wrong? Value 789A dot bat. Is it user init? 789A dot bat. What? Hmm. 789A dot bat. So well, at least I can find. At least I found the value data, but I want the value item name. Oh, so what? So it's going to be user init. Sweet. All right. What is the value data of the suspicious registry entry from question 1? C window. We want the suspicious. So C users, or is it C? Okay, so you want both of them. Okay, so they want both. C Windows system 32 user init.exe then we do C users administrator app data local, this is fun, THM 789A, there we go, dot bat. Sweet. What is the category that AutoRuns assigned to the entry from question 1? It is going to be, the category is going to be, category, log on. Nice. Log on. And when the suspicious file is ran, what happens? I believe I have seen this guy. Let me stay, my friend. Okay. Let me stay my friend. Awesome. Alright, task 6, conclusion. We can now take the necessary steps to remove the malicious registry files. Keys and files were found. In this case, it is easy as deleting or modifying the entries via regedit and ensuring they are gone after a reboot. So, we're going to go to regedit. We're going to go to HK local machine, software, Microsoft, Windows. Let's scroll down. Windows. I am missing something. Current version. Run. Right there. And it's delete that guy. So we're going to delete him. Yes. And not set. Be gone. And we have cleaned up that entry. Nice. Alright, so hopefully this room has given you an idea of how malware uses the Windows registry to maintain persistence on a lab machine. While there are other techniques that malware uses, the same tool can be used in detecting most of them. We saw AutoRuns. So, let's do congratulations. You've cleaned your machine of persistent mechanisms. For now. Yay. Awesome. Check. We did it. We completed the room. Nice. So let me go back. And and I can share it on socials. Nice. Alright, so we go back. And I will show split view. I will terminate the machines. So that way I don't leave anything running. There we go. And the helpful features I covered in this room were AutoRuns, the DFI reference for Windows Forensic Reference Tools, and also for my Linux folks, there's a Linux Forensic Reference as well. The Windows Registry Artifact Explorer, all artifacts, auto start and persistence, which can be found here, software installation execution, and much, much more. Malware indicators, execution artifacts, a lot of really helpful information. AutoRuns, the attack reference for persistence, such as boot or login auto start execution. And if we click on one of these, for example, registry run keys and startup folder, we will be taken to the MITRE ATT&CK webpage to learn more, such as boot or login auto start execution. And again, all credit goes to the author of the dfr-scripts.github.io, because it is a really beneficial resource that I highly recommend using in bookmarking. Also, here is the registry tools as well, such as Registry Explorer, RegRipper, Amcache Parser, Registry Spy, YARP, and much, much more. Alright. That's all I have for this walkthrough. I hope you guys enjoyed the Registry Persistence Detection walkthrough. I will see you guys in the next walkthrough. Have a great rest of your day and keep up the great work. Peace.